Okay, so today let's take a look at this LeetCode problem 532 K-diff pairs in an array. Given an array of integers numbers and an integer k, return the number of unique K-diff pairs in the array. A K-diff pair is an integer pair, numbers I, numbers j, where the following are true. So yeah, I and j is between 0 and numbers dot length, and I is not equal to j, a is smaller or equal to b, b minus a is equals to k. I think a and b here is the two numbers, right? Numbers I and numbers j. Okay, so we are given so many examples. In the first example, the input array is 31415 and the k is 2. The output is 2. So how this output is calculated? The explanation says there are two diff pairs in the array, 1 and 3, and then 3 and 5. And although we have two ones in the input, we should only return the number of unique pairs. Okay? In the second example, the input array is 1, 2, 3, 4, 5. Let's just use this one. So input is 1, 2, 3, 4, 5, and k is 1. So how many integer pairs we can have? 1, 2, 3, 4, right? We can have 4 integer pairs that the difference is 1. Okay, let's take a look at the third example. 1, 3, 1, 5, 4, and k is 0. If k is 0, basically we just need to find the duplicates, right? So 1 is a duplicate. Yeah, so just return 1. It's the only duplicate in the array. Okay, so I think after going through these three examples, at least a brute force idea we should come up with, right? And the idea is basically we just start from each index, right? Then we go through the remaining items in the array. If we satisfy the requirement, we increase the count. And since we need to return the unique K-diff pairs, I think we can use a hash set. Right, so let's code it. Let's first check the input. If input array is null or is empty, we just return 0. Then we define a hash set. We start from the first value. Then we just check the remaining items, right? So here it says B is always greater or equal to A. So we don't know in the input array whether it's sorted or not. So we're gonna use mass dot absolute, right? Numbers j minus numbers I equals k. We can add either the max value or the minimal value between the two into the hash set, right? Let's just do the minimal value. Yeah, eventually we return the number of value we have in the hash set. Okay, let's submit it. Okay, accepted. But the time complexity is pretty bad, right? You basically have to start from the first one and then check the remaining items. Roughly is an n squared time complexity solution. So can we improve it a little bit? So we need to find the K-diff value pairs. What I'm thinking is, what if I use a dictionary to store these values? Right? Oops. If I have values, say 1, 2, 3. So if k is, let's say k is 1, when I check value number 1, I just need to make sure 2 exists. Similarly, if I check number 2, I just need to know whether 3 exists. Right? And if k, this is a special case. If k is 0, right, we just need to make sure this number appears at least twice. Right? Will that work? Yes, I think we can give a try. So instead of using the hash set, we use a dictionary here. Then we store these numbers in the dictionary. Then we need a counter, right? We only check the keys, right? Key gonna be the number. Let's say key. So we have two cases as I mentioned here. If k is 0, we just make sure that particular number appears at least twice. Otherwise, we just need to make sure for that particular number, let's say k, then k, we need to check whether k, well, if that number is n, we just need to check whether n plus k exists. Right. Let's use number here because we want to use k. Okay, so two cases. If k is 0, meanwhile take number is greater than 1, or k is greater than 0, and we just need to contains key. We just need to make sure what is this? Okay, we just need to make sure that number plus k exists. In these two cases, we increase the count. Eventually, we return the count. Right, let's compile the code. All right, submit it. Well, this is okay. This is great, and yeah. So this just linear search on, right? And this part is also a linear search, and overall it's an on time complexity solution. And space complexity depends on the dictionary, right? The dictionary, yes, it's going to be a on time complexity solution. All right, that's it.